Hey everybody, how's it going? Thank you for joining me. I'm Corey. I go by coreyja online. You can find me at coreyja.com or as coreyja on GitHub, Twitch, and YouTube. And today we're going to be doing some Advent of Code. So Advent of Code is these daily programming puzzles that come out on the 1st through the 25th of December. And today we are going to dive into Advent of Code Day 13. So I am a few days behind now, but that is okay. We were working on 12 yesterday. Unfortunately, we didn't get both stars, but we're going to dive into Day 13 anyways. So let's get right going. Day 13, Point of Incidence. With your help, the Hot Springs team locates an appropriate spring which launches you neatly and precisely up to the edge of Lava Island. There's one problem. You don't see any lava. You do see lots of ash and igneous rock. There are even what look like gray mountains scattered around. After a while, you make your way to a nearby cluster of mountains only to discover that the valley between them is completely full of large mirrors. Most of the mirrors seem to be aligned in a consistent way. Perhaps you should head in that direction. As you move through the Valley of Mirrors, you find that several of them have fallen from the large metal frames keeping them in place. The mirrors are extremely flat and shiny, and many of the fallen mirrors have lodged into the ash at strange angles. Because the terrain is all one color, it's hard to tell where it's safe to walk or where you're about to run into a mirror. You note down the patterns of ash and rocks that you see as you walk, your puzzle input. Perhaps by carefully analyzing these patterns, you can figure out where the mirrors are, for example. And then we get some example. To find the reflection in each pattern, you need to find a perfect reflection across either a horizontal line between two rocks or across a vertical line between two columns. Oh, between two rows or a vertical line between two columns. Hey Opus, thanks for stopping by. We are on to day 13 of Advent of Code. Okay, and it sounds like we're dealing with some reflections and that kind of stuff today. Sorry, too many mice. Okay. To find the reflection in each pattern, you need to find a perfect reflection across either a horizontal line or a vertical line. In the first pattern, the reflection is across a vertical line between the two columns. Arrows on each of the two columns point to the line between them. Okay, so if we mirror here, then it's perfectly mirrored. Yep, like you can see that it's a mirror pattern of that. In this pattern, the line of reflection is the vertical line between columns 5 and 6. Because the vertical line is not perfectly in the middle of the pattern, part of the pattern, column 1, has nowhere to reflect and can be ignored. Every other column has a reflected column within the pattern and must match exactly. Column 2 matches column 9, column 3 matches 8, 4 matches 7, and 5 matches 6. Oof. I'm sorry you're not feeling good, Opus. Yeah, 102.3 degree fever is definitely just hang out in bedtime. Hopefully you can rest up and start feeling better. That's not a lot of fun though. I'm sorry. And then in the second one, there's a horizontal reflection. Same thing though. And you only do the ones that there's enough. To summarize your pattern notes, add up the number of columns to the left of each vertical line of reflection. To that, also add 100 multiplied by the number of rows after each horizontal line of reflection. In the above example, the first pattern's vertical line has 5 columns to its left, and the second pattern's horizontal has 4 rows above it. And then you get 405 when you do the math together. Okay, so this one's a little... this one I think we can brute force really easy, and I'm not even super worried about the performance for part 2, but we'll see what part 2 does for us. So it's just going to be parsing this, and then going in the rows and columns, making sure they match. I don't think we'll have too bad of a time here. Okay, so let's pull up our editor, and we're going to do cargo new to make a new crate. We want a binary. It's day 13, and what is it going to be called? Point of incidence. Point of incidence, and it's going to be named point of incidence. Awesome. We'll cd into that directory, and before we keep going, we are using a cargo workspace to tie all of our Rust crates together, And so I just have to add this to the manifest file, basically, that tells it what crates to care about. And now that we've done that, we can cargo run in the directory and get the hello world default output. And so let's start off by making a sample input with the contents of our puzzle. And then we'll do let sample input equals include string of sample.input. And then let sample answer equals part 1 of sample input. And then let's debug out our sample answer. Let's debug out a reference to it. And we don't have a part 1, so let's generate it. I actually want that to go above my main, though, I think. It's how I've been doing most of these. Okay, and then this is going to return just a number. I do like the to-do there. Okay, so now what we want to do is we have a struct that's called like a puzzle, maybe. And it has some cells, and it's just going to be a vec of yeah, we're just going to do characters this time. We're going to parse that to an enum. And so we're going to do let puzzles equals sample input dot lines. We're going to parse on each line. So each line we're going to map. Oh, actually, no. That's not what we're going to do. A sample input, we're going to split it on having 2 new lines in a row. We're going to split it on a blank line because that's what separates our puzzles from each other. And then for each of these, we're going to map and create a new puzzle, except we're going to create it by calling puzzle parse. Then we can go down here and do impl puzzle. Oh, a parse method. I'm not sure if that's exactly what we want, but actually it might be. This needs a to-do to compile. This can be simplified. And then like, I think I just want to collect that to a vec. I definitely want a vec of things here to deal with for each of our puzzles. Cool. And so what did it do for parsing puzzles? For our input, we go over the lines. For each line, we go over the characters. Yep, that's exactly what we wanted, actually. Perfect. Okay, so now we want to like have a method that can check whether it's a reflection along a certain axis. So like function is horizontal reflection, takes in a self and a index, which is a usize. So for is horizontal reflection, what do I mean by that? And actually, which way did they mean horizontal? They say vertical line and horizontal line. So this would be a horizontal reflection. And I've parsed it by going the lines and then characters. So we're reflecting on the lines axis, which is my first axis, right? Because I think it actually is gonna matter, right? And if I parsed it in lines, this is my X. Yep, lines, and then in each line, the character. So the second thing, yeah, okay, so it's really like kind of backwards of how I would think about it, but that's okay. So for the horizontal reflection, we're going on the Y's. A index is a line in the horizontal direction between 2 Y indexes. Indexes. Yep. Okay. So let's see what I want to do. Yeah, I don't know what. Oh, it's making them a horizontal reflection or something. That's not what I want to do at all. Okay, so horizontal reflection, where the between two. Oh, well, I called them Y's, but if I'm having them be the first one, it makes more sense to call those X's. I just need to be consistent about it more than anything, right? All that really matters is I'm consistent about it. But for the horizontal one, it's the second pattern, and the answer would be like I would think I would call that 4 because it's after 4. Yeah, I think I'd call that 4 in indexes. Okay, so I could do that though, right? I could say assert equals our second puzzles at 1 dot is horizontal reflection over this to be true. And so how would we calculate that? Well, we want to like get some pairs maybe. So I want to figure out how many pairs to reflect. Like you need to figure out how far you can go in either direction. So like let max distance equals the max of two things. Either it's index, like how far away you are that way, or yeah, cells length minus index. Yep, how far in either direction can you go? And then for distance in 1 to max distance, you have a top and a bottom row. I think I'm gonna need to add 1 to one of these as well, because we start with 4 and I want to look at like, I'm not sure why they numbered these with ones. It just makes everything a little more confusing. The line between columns 5 and 6. So I actually want the answer to be 4 in this 1 0 index thing. So if it's 0 index, it would be 0, 1, 2, 3. So it's 4, 4. Interesting. Okay. So this thing though, I want the answer to be I'm getting a little confused, and I think part of it is because Copilot wrote too much for me. Okay, so for the distances, let top equals index minus distance. Let bottom equals index plus distance plus 1, because you need them to always be offset anyways. So then these are the y's. So for, yeah, I like this basically. For x in the length of the thing, yep, if they are not the same, return false. And then if we get all the way through these, we can return true. So the max distance is either like how far you have from the left or how far you have from the right. So 0, 1, 2, 3, 4. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so there's 9 of them, so that would be 5. So 1, 2, 3, 4, 5, or 1, 2, 3, 4. Yeah, except this needs to be the min. It's the min, not the max, but that makes a lot more sense. So I think is horizontal reflection is not 4. What about is 5? No. Length is 7, but index is 7. I wasn't expecting that to happen either. Cells top. Yeah, aren't they the same size? I would also be surprised if they weren't the same size. Uh-oh. What is going on? I didn't even debug out our puzzle, so maybe we should just do that. Let's just look at the one we care about, right? Might as well. Those all look fine. They look consistently sized. The length is 7, but the index is 7. It doesn't tell me which one of these. It could be on either one. For x in 0 to the length of it. Oh, but is bottom too far here? Oh, we don't go to max distance. We go almost there. Nope, that wasn't it. The length is 7. Not yet implemented. Oh, okay. That at least got us to the not yet implemented with 5. With the answer being 5. But I think I'm confused about this. Max distance. Well, first of all, that's spelled wrong. Distance. Okay. So the max distance is, I don't like that these are 1 indexed, because that's just throwing me off. Okay, so let's do this. First of all, this is the one I'm looking at. 1, 2, 3, 4, 5, 6. Yay, look at that. Hey, Backward Spy, how's it going? Thanks for hanging out and stopping by. Oh yeah, it is late for you. Don't feel like you need to stick around. But thanks for stopping by, and thank you for the resubscription. Always appreciate it. Okay, so here, the answer being 5 doesn't make any sense. I want the answer to either be 3 or 4. Is horizontal reflection around 3? Oh, is it also a horizontal reflection around 3? Well, it shouldn't be. If 3 works, 5 shouldn't work, right? Because if we make a cut here, and that works, making a cut here at 5 shouldn't work, right? That's not a mirror of each other. So let's look at our logic here again. Is horizontal reflection. This max distance bit, I think, is the thing that is getting me. Okay, so actually no, we have our max distance. Maybe that's right. The top and the bottom indexes though. So our index here would be, oh, I don't want to look at that one. I want to look at the one that's here. So we have 3, and I want the answer to be, and actually, wait, what do I want the answer to be for this one? And it's above each horizontal line of reflection. So the number of rows above each. So 1, 2, 3, 4. Yeah. So like I want the number to be 1, 2, 3, 4. Yeah. 1, 2, 3, 4. So I guess I want 4 to be the answer here, right? Is horizontal reflection on 4. And if we're doing it on 4, then it's like the one above. So to get top, you go the distance, and you go 1 farther. Is there just a -1 on both of these? Or does max distance just go from 0? Is horizontal reflection at 4? But let's do something else. Function horizontal reflection is horizontal reflection. No. It is an option of a usize. And it's for I in 0, 0 dot dot self dot cells 0 dot length. Yeah. Manual implementation of iter find. Oh, okay, cool. So we're going to find the one here that is a horizontal reflection. And so now I can do horizontal reflection and get sum of 4 is what I'm hoping for. But we'll see if I'm just getting a different one. Attempt to subtract with overflow. Nice. Okay, so is horizontal reflection. So I want to say if index equals 0, because we're doing it at if I want 4 to be the answer, we're like going below where this index is. So this index is the first thing in the bottom half. So if this is 0, it can't be a reflection. We just have to rule that one out. And similarly, if you have the last thing, it also can't be for basically the same reason. So that's what that rule is going to do. Okay, so now we get sum 1 and we expect sum 4. So we expected 4 and we got 1. But no, let's go to my indexing because I think that makes more sense. So we still get 1. And it's above that. So yeah, those aren't the same. There's a character that doesn't match there. So let's print out the top and bottoms. But actually, let's get rid of this just a little bit. Let's do that. Oops. Well, that's fine. Is horizontal reflection of 1, and I want to get none back, but like the return value here is not the important part. Oh, this is false. I just want that to run though, so that I can see some debugs that I'm going to add in. Debug top and bottom. Yeah, I want to see the pairs here. Top and bottom are 0 and 0, and that's it. Where are our other debugs? And let's remove them. Don't need the cells anymore. Need the answer, and we need that. Perfect. So it's just doing top and bottom are 0. So that's not what I want. So the index. Our index is 1. And our distance is, what's our distance then? It would be 1 according to this, but is that what it should be? I keep going back to the 1 index. I need this one. Okay, so we're looking for a line. Oops. Like here. This is a down one. That's an up one. What's an up? What's a, oh, that. Yeah, like that. It's here. So the reflection is 1. The max is 1. Yep. So then if we go from 1 to the max distance, for the top one, you take our index and you subtract the distance. And for the bottom, you add the distance except subtract 1 to get you back to here since we were already in the right spot. Yeah, so I think that's what we want. because now we just get a panic of left doesn't equal right at here, but it doesn't even debug that at all. That seems a little suspicious. So I think it should. Yeah, sum 1. Yeah, oh, I see. So we expected to get false and got true. I wasn't reading that right. But why are we not debugging here? Oh, because we never get in this loop. But index here is 1. So 1 and then minimum of, oh, because we're subtracting 1 here. I didn't remember that. There we go. Okay. There we go. We finally got to our not impl, which means we finally got to the to do and made it past our assert equals. We can probably keep both of them in here. Nice, awesome. Okay. So now we got the horizontal reflection right, I believe. So let's do the other one. Assert equals puzzles at 0 for vertical reflection and get 5. So then function is vertical reflection at this index. Same thing here. If it's 0, we get the max distance exactly the same. We do this exactly the same, and it's left and right now, where left is minus distance plus distance minus 1 for the y's, and we left right. Yeah, exactly. Function vertical reflection. Just find the vertical reflection. Nice, made it all the way through. Means we've got all of those. Okay, so now we need to do the math here. So for a specific puzzle, it's either horizontal or vertical. So we want a function called reflection. Actually, no, let's just do, maybe I'll just leave both of these. Function value or something. Which just takes a self. Yeah, we'll just do value. And then so it's let horizontal equals self.horizontal reflection if let sum horizontal. Okay, so horizontal and 4, and the answer for this one is the amount of rows. The second pattern is horizontal, has 4 above it, so 4, so index, yep. So it's that. That just needs to be a return. Return that. Vertical, if vertical, and then so if it's a vertical one though, horizontal is times 100. It's just that constant thing. And then the vertical ones are not times 100. Panic, no reflection found. Perfect. Except for the vertical ones, it's number of columns to the left. So number of columns to the left, 1, 2, 3, 4, 5. So it's 5. Yeah, okay. I think, yeah, we got those right. Perfect. So then we just want to do, we just sum up the values now, I imagine. Summarizing all your notes. So puzzles dot iter map value sum. Nice. 1100. is the sample, but I don't think that's the answer we got here. We got 405. So not what we were looking for. So I guess let's debug out the values. Yeah, collect it to a vec. Oh yeah, no, we can still return it. It's wrong, but we can still return it. 700 and 400. So wait, in with 700 then 400. So this first one is 700 in the same thing. So 0 or 1, 2, 3, 4, 5, 6, 7. Yeah, well, you're not allowed to do that. I thought I said you're not allowed to be a reflection if you're that way. Index equals cells.length minus 1. Yeah, you can't be a reflection at that in that one. Yeah. What if I try to find the vertical reflection first? 405. I got the right answer this time. So the horizontal reflection, though, feels like it shouldn't have done that. Index equals cells dot length. Oh, did I do the wrong? Is this doing it the wrong way? And then is vertical. No. No, that's definitely the right way for that one. For a vertical reflection, we've got to look inside and do the length. Oh, it's not minusing 1. That is the length of it. There we go. And now if I go back to doing this in this order, which shouldn't matter. Dang it, attempt to subtract with overflow. Oh, I guess I should exclude both of those. So it's minus 1 index is greater than or equal to that. There we go. And then this one wants to be the same thing. If this is greater than or equal to the length minus 1, that covers both cases. It doesn't matter at the moment, but that is what we want. Okay, now let's grab my input. New file, my input. Drop it in. I think I can get rid of this now. Let's keep it. Okay. Let my input. Let my. Oh, this is sample part 1 answer. And then this is my part 1 answer. Debug out my part 1 answer. And that's actually all we need to do right now. Oh, yeah. These only made sense for the sample. And we just don't need that debug anymore. No reflection found. Uh-oh. Length minus 1 from 1 to length minus 1. We don't even count it. And then I think I actually just don't even need this at all. Still the same. Oh no, but then that does that again. But I think that's just because we're going too far here. These are both just to 2. Yeah. Wait, no reflection found, but I think we got that no reflection found now on the sample too. Okay, let's go back a little bit. Let's go back to the ones where we were getting the right answer. There we go. That at least gives us 405. And then no reflection found. What else do I have to panic with there? I'd like to know a little more about it. I guess I can just have it return 0 at the moment. I kind of want to know which one was panicking. Oh, I guess I could just debug it out. Debug, cells. Let diagram, nope. Let s equals self dot cells dot iter dot map collecting to a string. Yeah, exactly. And then print line of s. Okay. No reflection found. But am I supposed to do something if there is a reflection, right? Is what they're saying. Number of columns. I guess that's fair. If I do zeros, what number do I get? Because I'm not positive that's wrong. But I think this is going to be wrong. Yeah, cool. I assumed that there was going to be a reflection in all of them. So if I look at the ones where there's it says there's not a reflection and I can find the reflection, then we are in a good spot. So let's actually take this and put it in a, oops. Well, that is where I wanted to put it, but it didn't work. Try this again. There we go. Now did it finally get, nope, Nope, this one. There we go, okay. Where do I see something that looks like, yeah, right here. There's a reflection right here. Where like this one goes down and this one goes up. There's a reflection. There's a horizontal reflection at, I think we call this 8. Yeah. So let's call this in our source failing.input. Because then we can go to main and let's do let failing input. Let failing puzzle.parse it. And let's debug out its value. Yep. Awesome. And it's no reflection found, which we knew already. Just confirming that we got the same thing. And then so let's do assert equals failing puzzle. That's not what I want though. Failing puzzle dot horizontal reflection is sum of 8. And it's obviously not going to be, but then I can actually let's do is horizontal reflection on 8 to be true, because that's the easier one to debug. No reflection found. Yep. Okay. So let's see why that's not a horizontal reflection. So I assume we are getting down here. 5, 6, 5. Top is 5, 0, 1, 2, 3, 4, 5. Bottom is 6. What? 0, 1, 2, 3, 4, 5, 6, 7, 8. Yep. And if we're downing it this way, then I would go that way, right? 4, 5, 5, 6. Why are these always one apart from each other? I feel like they're not supposed to be. Oh, they are when they're... No, because we're supposed to be looking for multiple distances. X is 0. X is 4. X is 1, 2, 2, 0. X is 5. Index minus distance. Index plus distance minus 1. Oh, so let's get distance in here too. That's kind of what I thought X was for a second. Distance is 1 here. Because at 8... Oh, well, okay, I guess it doesn't matter that, but distance is 1. But that doesn't make sense to me what's going on here then. So we're only returning when we hit a different one though. Wait. I have a lot more debugs here than I think I should if we're hitting the return false one. Where do I have more debugs? That's the only one I have. Return false. Oh, but then I'm doing more stuff before failing because I'm calling value. Yeah, okay. So what I actually want to do here is just do a to-do. There we go. And now we're not hitting the debugs at all because we aren't actually hitting this. Are we hitting this? Oh, wait, so that's true? Wait a second. No reflection found. Okay, well, wait a second. Horizontal reflection. Are these backwards? No reflection found again. And are we still just doing the 1 here? No, I'm not. Not yet implemented. Oh, okay. Because is the assert equals value and like 800, I think, is what I expect that to be. Yeah. Okay. So now we have a new error. Okay, so failing is whatever. There's another one that's failing with no reflection found. Okay. Awesome. Go back to main. Take this back in. It's just gonna fail immediately on that though. No reflection found. But what kind of reflection do I expect to find here? I think there's one right here. Yeah, that looks pretty reflective. Vertical at 4. 1, 2, 3, 4. Yeah, I think there's a vertical 4. So the value out of it should just be the number 4, I think. And then is vertical reflection at 4. Yeah, so it's not a vertical reflection at 4. Got it. So why not? Oh yeah, they're all different. That's okay. Left, right, Y. Left, right, Y distance. 164. So 0, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. But I think I wanted it 4. So if it's 4 with a distance of like 3, 1, 2, 3. Yep, and then 1, 2, 3. Oh wait, does that mean that actually isn't? Oh, okay, yeah. So that's just not actually right. Okay, that's fine. That just means I mistook it for 1. Which I think is right. I don't think that actually is a mirror. Yeah, no, it's right. That's not a mirror for that line. Okay. Where's a different mirror image? Nope, not one there. I guess there's one here, right? Yeah, I think it's the bounds again. I think it's always the bounds. Index is 0. We can't do because you can't go below it. Index of the last one. Index equals the length. Well, what does max distance just constrain this in and of itself? Oh yeah, for assertion failed there. Well, that it actually kind of is supposed to fail. Oh, but we just get zeros now across the board. Oh yeah, one of these we do need to rule out though. We need to rule out the zeros. I forgot. I don't think we need to rule out the top the top side though. Because we can go all the way to the lengths. Oh, we hit a to-do. Cool, where's the to-do? Didn't mean to leave a to-do in there. There we go. Nope, my part 1 answer. There we go. Okay, let's get rid of some debugs. Not that one, though. That's a good one. That one we'll get rid of. That one we'll get rid of. That one we'll get rid of. Awesome. In failing, we'll just get rid of that altogether. Perfect. Yay! Day 13, part 1. Let's go to part 2. You resume walking through the Valley of Mirrors and smack! Ran directly into one. Hopefully nobody was watching because that must have been pretty embarrassing. Upon closer inspection, you discover that every mirror has exactly one smudge. Exactly one thing that should be the opposite type. In each pattern, you'll need to locate and fix the smudge that causes a different reflection line to be valid. The old reflection line won't necessarily continue being valid after the smudge is fixed. Here's the above example again. The first pattern's smudge is the top left corner, and the top left blank were replaced by that, it would have a different horizontal line of reflection. With the smudge in the top left corner repaired, a new horizontal line of reflection between rows 3 and 4 now exists. Row 7 has no corresponding reflected row and can be ignored, but every other row matches. In the second pattern, the smudge can be fixed by changing the 5th symbol on row 2 from a thing to a thing. Okay. So I think we want now, summarize your notes as before, but now instead use a different reflection line. Oh yeah, just a different reflection line. Yep, okay. Fix the smudge and find the different lines of reflections. What number do you get after summarizing the new reflection line in each one? Okay, so I think what we were doing before basically was we counted it as a reflection if they all matched, right? So like is horizontal reflection returns false here if it's not a reflection. But I think what we're going to do is count how many things were different. So like count the differences here. So instead of returning false, we increase the counter, and at the end we count the number of differences. And I think we do that so that we can find ones where there's a reflection with only one difference, and those are the ones where we want to say that's the smudge. Yeah. I think that's right. So how do we want to go about setting this up? We need a part 2. And so we don't want value anymore. This is like part 2 value. We can just make a part 2 value. Function part 2 value. So horizontal reflection. And so now what if horizontal reflection actually took in the number of differences? As a U size. And then that got passed to the is horizontal reflection with num differences. And we just do the same thing with the vertical reflection as well. Yeah, is that what I want to do? Maybe. So then let mutable differences equal 0. Return. This is now differences plus equals 1. And then this is differences equals number of differences. Yeah. Let mutable differences equals 0. Differences plus equals 1, and then we do if differences equals the number of differences. So then that's awesome. And then for 0, we want 0 differences. And for part 2, we want 1 difference. And then that is all we need to do. Let sample part 2 answer, debug sample part 2 answer. We got the same 405. Oh, because we need to wait. That doesn't make sense. How do we get the same 405? Oh, because I'm not doing this yet. Part 2 value. Easy answer. Answer's 400. 400. Okay. Nice and easy there. Let my part 2 answer debug my part 2 answer. Nice and easy, hopefully. There we go. That's the right answer. Awesome. Oh wow. Day 13, part 2. Nice. So that was nice and easy. I like when part 2 is very quick and easy on top of part 1. So I want to refactor just a little bit, mostly just some naming. So horizontal reflection, I think it's fine for that to take num differences like that. I don't like horizontal reflection like this. So like, I think what this is really going to be now is change it to count horizontal count differences horizontal reflection. Horizontal reflection count differences. Yeah. Horizontal reflection count differences. Awesome. Um, and it's going to return the count of differences in an option. So there are some differences there. This one we didn't even try, so it's a none. It's a option of a U size. So then, and we actually don't take in num differences at all anymore. And we want to find one where the number of differences is what we asked for. So we're just going to restructure that a little bit. And then of course I did it for the wrong one, which is kind of funny. Just got to do for both of them eventually anyway, so not a big deal. Of a U size. That's the one thing I needed there. This then doesn't take that, and it's equal to some num differences, and then this is gonna get renamed to something like that, except this is vertical. Okay, so horizontal reflection for the num differences, it finds the count that equals the number of differences it's looking for. Yeah, it's basically exactly the same as before. I just renamed some stuff. Yeah, same answers. Rename some methods for clarity. It's not exactly the same. I did change the return values, but I think it makes more sense to have something that counts the number of differences and then do the comparison on the outside. Instead of passing the expected number in, it just wasn't necessary. And with that, I think we're gonna wrap up for the day. Let me push my code. There we go. And yeah, I think that is gonna do it for today. Thank you for coming and hanging out with me as we did Advent of Code Day 13. As I said at the beginning, I'm Corey. I go by coreyja online. You can find my blog at coreyja.com. If you enjoyed this, you should subscribe to my newsletter. Head over to my blog and click on newsletter here, and then put your email down in this little box, and I will send out a newsletter to you. I want to say every week. It was called weekly at the beginning, and I haven't sent them out very frequently, but I would like to get back on the weekly cadence and get them out on Fridays. So if you enjoyed what I'm doing, please subscribe to my newsletter and be the first to know about everything happening in the coreyja universe. And with that, I'm going to get out of here, team. Thank you all for coming along, and I will talk to everyone online. Thanks. Bye.